Hey everybody, welcome back. Excuse me. And if you'll forgive me if I'm coughing a lot, I kind of hate this section. I don't really dislike the information so much as I'm not a big fan of its being introduced at this point, mainly because the short-circuiting evaluation is something that I don't think really is useful at this point. However, this is a read-through, not a judge-through, so we're going to go ahead and read it. Automatic type conversion. In the introduction, I mentioned that JavaScript goes out of its way to accept almost any program you give it, even programs that do odd things. This is nicely demonstrated by the following expressions. Constant.log 8 times null, so we got the number 8, the operator multiplication, and our null, which is like our empty value, and that's going to be 0 for some reason. Constant.log string 5 minus 1 is going to give us 4, and spoiler alert, it's actually a number 4. Console.log string 5 plus 1 is going to give us 51. That's actually string 51. So for string 5 minus 1, we get the number 4. For string 5 plus 1, we get the string 51. String 5 times 2 is going to give us not a number. Console.log false is equal to 0 is going to give us true. So okay, when an operator is applied to the wrong type of value, JavaScript will quietly convert that value to the type it needs using a set of rules that often aren't what you want or expect. This is called type coercion, or type conversion as it will be referred to sometimes. The null in the first expression becomes 0, and the string 5 in the second expression becomes 5 from string to a number. Yet in the third expression, plus tries string concatenation before numeric addition, so the 1 is converted to a string 1 from a number to a string. When something that doesn't map to a number in an obvious way, such as the string 5 or undefined, is converted to a number, you get the value not a number. Further arithmetic operations on not a number keep producing not a number. So if you find yourself getting one of those in an unexpected place, look for accidental type conversions. When comparing values of the same type using double equals, it'll become obvious in a second why I'm calling it double equals, the outcome is easy to predict. You should get true when both values are the same, except in the case of not a number. Excuse me. But when the types differ, JavaScript uses a complicated and confusing, it's not so much confusing, but it is complex, meaning there's like a ton of rules to determine it, which is probably confusing. So let's go ahead and leave it as that. JavaScript uses a complicated and confusing set of rules to determine what to do. In most cases, it just tries to convert one of the values to the other value's type. However, when null or undefined occurs on either side of the operator, it produces true only if both sides are one of null or undefined. So if we say console.log null double equals undefined, we're going to get true. If we console.log null is double equals 0, we're going to get false. Okay. Excuse me. That behavior is often useful. Yes, that behavior is often useful. When you want to test whether a value has a real value instead of null or undefined, you can compare it to null with the double equals or not double equals operator. But what if you want to test whether something refers to the precise value false? Expressions like 0 double equals false and empty string double equals false are also true because of automatic type conversion. When you do not want any type conversions to happen, there are two additional operators, triple equals and not triple equals. The first tests whether a value is precisely equal to the other, and the second tests whether it is not precisely equal. So, empty string triple equals false is false as expected. I recommend using the 3-character comparison operators defensively to prevent unexpected type conversions from tripping you up. I'm going to say that again because it's an absolutely fantastic idea. Well, actually, I'm not going to say it again. I already said it, but I highlighted it, so there you go. But when you're certain the types on both sides will be the same, there is no problem with using the shorter operators. Short-circuiting of logical operators. Now, this is why I dislike this subsection, because I'm not sure this really matters to somebody at your somebody who is in a beginner status. I don't think should care about this, but perhaps this book isn't completely meant for beginners. Nothing really we need to worry about too much, though. The logical operators and or handle values of different types in a peculiar way. What I mean by not having to worry about it is more like just read it now, keep it in the back of your mind, or it'll keep itself in the back of your mind. As it comes up more and more, you'll kind of get used to this idea of short-circuiting and what they're describing in this section. I feel like it's just a little bit heavy at this point. So, peculiar way, they will convert the value on the left side to Boolean type in order to decide what to do. But depending on the operator and the result of that conversion, they will return either the original left-hand value or the right-hand value. The OR operator, for example, will return the value to its left when that can be converted to true, and will return the value on its right otherwise. Which is cool, right? Because if we look at this console.log, it's like, well, null here is going to be converted to false in a Boolean setting. So this expression, which theoretically should yield a Boolean value, is going to give us the right value that could be converted to true. If we have one in the left that can be converted to true, we get that one. So let's return back to the book. This has the expected effect when the values are Boolean and does something analogous for values of other types. We just saw that. We can use this functionality as a way to fall back on a default value. If you have a value that might be empty, you can put OR after it with a replacement value. If the initial value can be converted to false, you'll get the replacement instead. The rules for converting strings and numbers to Boolean values state that 0, not a number, and the empty string count as false, while all other values count as true. So 0 or -1 produces -1, and empty string or a string with exclamation point and question mark yields the exclamation point and the question mark. You should also note that in addition to 0, not a number, and the empty string, null and undefined also do the same thing. As we saw here, this converts to false. If this was undefined, the same result would happen. The AND operator works similarly, but the other way around. When the value to its left is something that converts to false, it returns that value, and otherwise it returns the value on the right. So when the value to its left is something that converts to false, it returns that value. So let's have a look at this. This is actually worth a demonstration. So we've got our console.log of a value that is going to go to false and a value that is not going to go to false. So if we console.log this, according to the text, we should get user. Let's go ahead and run this. Excellent. If we say AND, I believe the book is indicating that we're going to get this value. Okay. Now what would happen if we did both as values that would evaluate to true? So we get the one on the right. And okay, yeah, the reason I don't like this is because it's demonstrating something that is a useful concept after a bunch of other programming paradigms and tools are going to be introduced. You wouldn't actually start trying to use the short circuit operation at this point. We really need to build a lot more complexity and logic into our programs before it would make sense to do that. But, to each tutorial their own, and let's just go ahead and keep operating. Another important property of these two operators is that the part to their right is evaluated only when necessary. In the case of true or x, no matter what x is, even if it's a piece of program that does something terrible, the result will be true, and x is never evaluated. The same goes for false and x, which is false and will ignore x. This is called short circuit evaluation. Again, the biggest question for a lot of people is why, and as far as I'm concerned, this is a gigantic why inducer. When you read this, it's just, why? But eventually you will come to the appreciation of like, oh, that's why. But for now, just keep it in mind, something called short circuit evaluation, Booleans, that's pretty much fine for now. The conditional operator works in the same way. Of the second and third values, only the one that is selected is evaluated. And that's that whole question mark colon. That was our conditional operator, or the ternary operator. So with that, next section is going to be the summary, and that'll be the end of chapter 1. Thanks for watching. Hope you enjoyed it, and we'll see you in the next one.